Hi, Mr. Fahey. Okay, so I'm Amy, and then my partner is Lucy, and we're in your 16th, 17th class. And then this is, okay, we start out here, equation for a graph. X over 9 squared plus y over 3 squared equals to 1. And from the equation, we can see that x is the major axis, since 9 is greater than 3, so we get negative 9, 0, and 9, 0 for vertices. And since b is 3, we have 0, 3, and 0, negative 3. Okay, so number 1 is the motion begins at 9, 0 is clockwise and requires time seconds for a complete revolution. So our current metric equation from our original equation is x equals to 9 cos pi over 5t, and y equals to 3 sin pi over 5t. And pi over 5 is our b, and we get that from this equation, which is t equals to 2 pi over b, and we get b from 2 pi over t. And so our equation, okay, so we start at 9, 0, and we rotate clockwise, so we go this way. Problem number 2. The motion begins at negative 9, 0 is clockwise and requires 8 seconds for a complete lap.
So to find the parametric equation, you need to find omega first. And omega is 2 pi over t. And t is 8 seconds, so you replace t and you get pi over 4. And then so you put it into the parametric equation and you get x equals 9 cosine pi over 4 t plus 4, and also y equals 3 sin pi over 4 t plus 4, because it takes 8 seconds for a whole complete rotation, but when you start at negative 9, 0, it will take only 4 seconds to start. So the graph for number 2, you start at negative 9 and 0, and you go clockwise that way.
The motion begins at 9, 0 is counterclockwise and requires 20 seconds for one lap. So first we find omega, and it's 2 pi over t, so we plug in 20 seconds, and we have 2 pi over 20, and it simplifies to pi over 10. And we plug that into the equation, x equals to 9 cosine pi over 10t, and y equals to 3 sin pi over 10t. And our graph moves in a counterclockwise direction, so it moves this way, and it begins at 9, 0.
For number 4, the motion begins at negative 9, 0 is counterclockwise and requires 12 seconds for one rotation. To find the parametric equations, you have to find omega, and you would get pi over 6. And for your parametric equation, it will be x equals 9 cosine pi over 6 t plus 6, and y equals 3 sin pi over 6 t plus 6, because it begins at negative 9, 0, and that's half of the rotation. And so it goes from 12 to 6, and it will go counterclockwise, so it will move this way.
Number 5. Do the same as above, but rewriting the equations to accommodate the other two initial conditions and directions of rotation. Let the time per lap be 12 seconds in all possible scenarios. So for number 5, we have to find omega first, and it will be 12 pi over 12, and that simplifies to pi over 6. So like before, it will be x equals to 9 cosine pi over 6t, y equals to 3 sin pi over 6t, and it will go in a clockwise motion, so it will go this way. Number 2. Motion begins at negative 9, 0, is clockwise, and requires 12 seconds. So omega is pi over 6 again, and x equals to 9 cosine pi over 6 times t plus 4. Y equals to 3 sine pi over 6 times t plus 4. And it goes in a clockwise motion, so it will, starting from 9, 0, so it will go this way.
Okay, for number 3, the motion begins at 9, 0, is counterclockwise, and requires 12 seconds. So the parametric equation is x equals 9 cosine pi over 6t, and y equals 3 sine pi over 6t. And the graph will go counterclockwise. And for number 4, motion begins at negative 9, 0, and goes counterclockwise. So the parametric equation equals x equals 9 cosine pi over 6 t plus 6. And y equals 3 sine pi over 6 t plus 6. And the graph will go, starts at negative 9, 0, and goes counterclockwise.